We'll visualize different types of data in this session. We will start with visualizing some categorical data. And let us say we have the color preferences indicated by a group of 15 students. And we would like to know which are the more preferred and the less preferred colors, or the overall distribution of these colors among these 15 people. So we need to pre-process this data before we can visualize it. First is we need to identify what are the unique categories that are there in the data. So for that, I will go and remove the duplicates. We have this option here, remove the duplicates, and we are only left with the unique colors. There is no order in these colors, so they can be in any order. Next is we do the count of the occurrence of each of these colors in the data set. How do we do it? We do it using countIf. And specify the criteria blue. So we know that there are 2 instances of blue color in this data set, 3 of red, 1 of green, 2 of yellow and purple each, and white has the highest frequency of 5. Now we can visualize the data using this process data. Simply go here, indicate, choose the column chart, and do some rearrangement. Now here we can visualize this data. There is no order here. If we wish to have them in the order of ascending or descending, we can just go and sort the count in the descending order. So we know now we can see that white has the highest frequency and green has the lowest frequency. Another way we can visualize this data is by creating a pie chart, which will tell us the relative importance of these color preferences among the students. So here we have these arranged in the pie chart. We can change the legend to actually represent the color. Change the fill. Let's make white white. And make red in color. Blue in color. Yellow is already yellow. Let's make purple. And green. Now we don't see this white clearly here. So what we can do is we can give it an outline. Let's give it a black color outline so that we can see that there is a white color pie here. So we can see the relative frequency of each of these. We can similarly give the outline color to all of these color preferences. So this is how we represent the categorical data where there is no order. Let us look at the preferences for the categorical data which has some order. Let us say we have the record of 50 students and their scores are available with us, and there is a equivalent letter grade, and we would like to see the distribution of these scores that the students have secured in the exam arranged by their letter grade. So for doing this, we are going to use the frequency count of the number of scores falling within a particular range of values. So typically, the way the Excel formula is designed is it would pick up the upper bound and will recognize the lower bound as the upper bound of the earlier class. So if you can figure out the upper bound, we can do the count of the frequency within these two boundaries. So the upper bound is 100, 89 here, 84 here. I think it was trying to autofill it. I do not know if I have an option to do a flash fill. Oops. So let's 24, 69, 64, 59, 54, and 49. Now we can do the frequency count of these values within the range of the scores. So we have to select this set of values cells where you would like to calculate this. And use the formula frequency data array. And specify the bin array. Bin array is here. We close. So we are able to see that it has added the additional 0 for the leftovers, which is of course 0 because this goes right down to 0 anyways. And the another way we can do it is just leave one cell empty and put the formula. Right, we only specify the one up to 54. It will pick up the next boundary and put the values from there automatically. Let's see if it picked up the values correctly. Yep, it picked up the values correctly. So now we have the data which is ready for visualization. For visualization, we will select these letter grades, press the control key and select the frequency. And then go ahead and insert the column chart. And we are able to see the data visualized in the specific order of the letter grades. So here the order is important, but the values are categorical in nature. So these are the two cases of non-metric data visualization. Let's move on to visualizing the metric data. Let us say we have the age of 50 students studying in a class available to us, and we would like to see the distribution of the different age groups in the class. For that, we will select the age column, paste it, data, remove any duplicates, and let's sort it in the minimum to maximum because there is a order. Next, we can just simply calculate the count if and the age. So we got the distribution of the age of the students here. Now we can simply go ahead and generate the chart here. Now we only want to put the count on the y-axis. Now we don't see the age on the x-axis, so we just specify it by selecting the data, edit, and specify where our, okay, I need to move it aside. Select, edit, and specify. Now we will be able to see the right labels under the respective frequencies. Right? So we see largely students are between 23 and 25, maybe 26, 23 and 26. And then we have a few exceptional, low number of students in the other age groups. Since there is no multiple data series plotted here, so we can just remove that legend. Here we have the number of categories, which are 11, but many times it may not necessarily be the case. In such a situation, we would intervalize the numeric values and plot the chart for the numeric values. So let us look at this. We have the commute time of the 200 students, and we have the commute time ranging from 15 minutes to 90 minutes. So we can decide to create some categories here. Let us say we make it 0 to 15, and let's say 15 to 30, 30 to 45. So here what I'm saying is 15 will be included in the upper category, but the 15 will be excluded in the lower category. 5 to 60, 60 to 75, and 75 to 90. Now we can represent this as an interval, and we can do it using the concat function, or we can even manually write it down. So let us say we use a formula concat this value comma hyphen comma the other one. So when we use this formula, we can see we are able to create these interval categories. We have the upper bounds, so we can calculate the frequency. We'll only select the values from here, and it will fill the last value automatically. Frequency, where is the data, comma, the upper bound, bin array, and close it. And when we enter the formula, we get the distribution of the commute times for different time intervals. And we have got all 200 of them here. Now we are able to do the frequency plot of this. So we can see the distribution of time. A large number of students more than half the class takes 45 minutes to 1 hour to come to the university. Yeah, 45 minutes to 75 minutes is the majority of students' commuting time. All right, so let's look at two more types of visualizations. Let's look at scatter visualization. Let us say we want to plot the amount of time a student studies and the score that the student achieves in the examination. So here we can actually plot them by plotting a scatter plot. To insert, we have the option of scatter plot. And here we are. We can see the number of hours a student studies is between 0 hours and 10 hours. Of course, the first record starts at 2 hours and the last record goes up to 9 hours. The minimum score is somewhere slightly higher than 50, that's 53. The highest score achieved is 94. And we can see as the number of hours of study increase, the number or the amount of score in the exam also increases. So this is a scatter plot which helps us see the directionality of the relationship, whether it is inverse or direct. And the nature of the relationship, is it a straight line or a curve? We largely see this looks like a straight line. We can right click and add a trend line. And we have an option to even display the equation which fits into this. Increase the font size to see the values. So here we see that for every hour of study, the score goes up by 5.659 marks for every additional hour of study. That's what it implies. So Y is the score and X is the number of hours a student studies. Let us look at the box plot visualization. Let us say we have the record of 244 customers at a restaurant where we know the head of the party is male or female, day of the week that the people are coming there for food, whether they are coming for lunch or dinner, and the amount they spent. So we can choose, let's say, meal that they take and the amount they spend on the meal. Insert, box plot. And we see that people tend to spend more money during the dinner time. And here we can see that we have this block which represents the first and the third quartile. And this line represents the median. And these, of course, represents the 1.5 IQR on the other side. And this dot represents the outliers in the sense that they are more than 1.5 IQR away from this box. We have looked at lunch and dinner. We can also look at day and the amount as well. Insert. And we notice that people tend to spend the median spend on Thursday is higher than Friday, and Saturday and Sunday is the highest. And these X indicate the mean value. So the amount spent on the weekend is comparatively higher than on the weekday. Similarly, we can make a plot for the gender also, who gives more tip or who spends more money at the restaurant. Insert. And we see that male tend to spend more money compared to the females, and the maximum being 50.81 for males and 44.3 for the females. So this is how we do the visualization of the data. We have looked at non-metric categorical data, that is nominal data. We have looked at the non-metric ordinal data, that is the grading in the order. We have looked at the metric data when we have few distinct values, unique values in the data, versus when we have many distinct values in the data. Then we looked at scatter plot for relationship between two metric variables. And finally, the box plot, which of course also shows us the 5-number summary of the data.